What is the root of all performance problems? I've asked myself some time ago, and I found two most common cases in my life when I have performance problems. First case, I have to do something, so I have some requirements. After that, there is that fun part of coding. After that, I can deploy my stuff. User can load his data, and we have performance problems. Case number two, as always, we have some requirements, working time, and we have performance problem. So our deployment is delayed. In both those cases, I'm sad because I have to fix it, and it's hard. I will create a lot of bugs, so I will have to fix it later. I don't have time, so I have to work in a hurry because we deployed something that acts really wrong. Our boss, he's not happy because it's not working as it should be. And let's say that some things will never change and user will not forgive us if something works slow. My name is Kamil Gałek, I'm front-end developer at SoftwarePlant. Today I will show you small fixes for huge performance problems. This speech won't be about AOT build, on-push strategy, webpack code splitting, service workers, or even lazy loading. It's a really cool stuff, but you will find easily a lot of resources on the internet, so please Google it. If you don't do these things, probably you should do it first. Okay, presentation will be cut short based on my personal experience. All the code examples, every slide, every additional resource you will find on my repository on GitHub behind this QR code. So please take a photo of this slide and let's go. Let's start with really important thing in performance matter. Performance is hard. To work with performance, you have to know a lot about JavaScript, browser, Angular, and a lot of really complex things like rendering in browser. So let's try to find some resources on the internet. And let's try first find something about front-end performance on Amazon. As you see, car parts. Somehow. So maybe let's try to find something about Angular performance on Amazon. Yeah, we have some JS or object-oriented programming with Angular, but we are still 30 miles from nowhere if we're trying to find a good book about performance in frontend. So maybe let's try to find something really specific like V8 performance on YouTube. Cars again. I don't know why, but it looks that front-end guys love cars, and probably every argue in front-end looks like this. Let's start with basics. You have to know about your data. Somehow all my performance problems was connected to data. We have a lot of rows to display, or data was so strange we have to transform it, and we had a lot of problems with this kind of data. Second one, tools. You have to know how to measure performance because you cannot fix anything if you don't know how to measure it. It's really important. And last one, strategy. It's the way of fixing things. If you have a good strategy, you will probably find the best solution faster than having a bad strategy. So, let's start with our example now. We have that app created with Angular. It's just a table with 5,000 rows, 7 columns. We have that row highlighting, it's quite laggy. And it's all. Only a table, 5,000 rows, 7 columns. So we have about 5,000 rows, 7 columns, 35,000 cells to render, and it works slow. Believe me, we will measure it. Let's start with load time performance. We will open that DevTools and we will try to start profiling and reload page. It will record the profile from reload to fully load page. So, as you see, it works pretty slow. really, really slow. Okay, probably we can stop now. Processing. Even processing is slow. Okay, we have 7 seconds of scripting over 6 seconds of rendering, which gives us about 13 seconds. Let's try to render only a data without Angular, without any component, only a data in the table. So we have row branch here. It works faster, of course. As you see, we can again measure it. Let's try it. Okay. So we have about second of scripting and second and a half of rendering. So 2.5 seconds. And it's like this situation. To be clear, this is your app, this is your user, and this is you. You have to fix it. Senior and junior have to fix it. So from 2.5 seconds of raw data loading to 13 seconds of Angular, we have over 10 seconds slower app. It's like a decade for your browser. So let's start with fix number 1. Probably your structure is too complicated, so let's try to reduce number of blocks on your page. Main idea behind this is that if you have less blocks to render, probably it will render faster. So let's go to that repository. We have structure cleanup pull request here, and as you see from complicated template like this one, we're going for the simplest one like this one. I've moved all the styles, everything to my host element, and it's all. I've repeated those steps for every component that I have. After that, we have that branch called structure cleanup here. I recorded all the profiles, so we don't have to wait 13 seconds each time when we want to check something. As you see, from 7 seconds of scripting and 6 seconds of rendering, we are going for 5.5 seconds of scripting and 2.5 seconds of rendering. And it's over 5 seconds of difference. If 10 seconds is a decade, 5 seconds is 5 years. And it's a lot. So fix number 2. We have 5,000 rows. Each one have 2 even listeners. Probably we want to reduce it. So if we have 5,000 rows, we have 10,000 even listeners, and we can reduce it just to even listeners. Let's go for code. We will find it in the pull request called listeners. Here. And we have 4 files changed, about 100 lines. I've removed that from event from my row component and moved it to create component here, and it's all. We have recorded profile here, so we can close the structure cleanup, and from 7 seconds of scripting, 6 seconds of rendering, we have 6.5 seconds of scripting, 6.5 seconds of rendering. It's about half a second faster app. It's like half a year. Not amazing, but still not bad, and you want to have half a second faster app. Fix number 3, probably the most related to Angular, ngZones. ngZones is that cool mechanism of Angular that will run change detection for you if something asynchronous occurs in your app. And it's good to have this mechanism when you have small app, but when things gonna complex, you want to disable it, because Angular is created to allow you create these small apps like landing pages and huge enterprise apps. And in my opinion, if you're creating something more than landing page, you probably should disable ngZone. We can manage change detection by hand. It's nothing bad, it's quite simple. So let's go for code. As always, we have pull request called ngZones, of course. Here, it's the simplest one here. We have about 10 lines changed. We provided noob zone here. And of course, we have to deal with change detection manually. And you have to know that it will not improve our load time, but it will improve that row highlighting function. Here it's quite laggy. And we have that ngZone here. Look how smooth it works. Again, laggy one, smooth one. Only 10 lines of code. So, as I said, load time will be without changes, but a way better performance of row highlighting and other things related to change detection, because we reduced a lot of change detection cycles. We can manage them by hand now. Let's go back to strategy. As I said, it's really important to find your own way of working with performance. My way is that I'm always trying to cut the slowest part of my app, and for now it's working for me really well. So the main problem with our app is that we have 35,000 cells to render, and most of it are not visible for user because we have scroll. So we should reduce this number of cells. The most popular solution for this problem is that kind of paging. I really hate it because it's bad UX. You have to click a lot of on the next button, and it's not friendly for me. So fix number 4, virtual scroll. The main idea behind this fix is that we have screen and list. List is much higher than screen, so we have that visible part and not visible part of list. And we are simply will try not to render those not visible parts. And that's all. It's really that simple. You can use lib for it. CDK have implementation. You will find a lot of cool stuff on GitHub. But I can really recommend you to implement at least your own solution, because it's quite simple and it's good to know how it works. Let's check the code. Pull request called VPR. And we have only 3 files changed, about 100 lines of code. If you want to analyze it, you will find it in my repo, so I will show you that QR once again. Please take a photo and you can analyze it at home, because it's 100 lines of code and I won't explain every line now. Okay, so we have that VPR branch here. Let's try to record it. We have that performance here, and once again we are trying to profile it. Okay, we can end. So we have master branch over here. We'll move it from 7 seconds of scripting, 6 seconds of rendering to 300 milliseconds of scripting and 100 milliseconds of rendering. It works almost immediately now. We can remove the tools, we know how it works. And as you see, even that row highlighting things is smooth. Scroll works, everything is good. So it's about 12.5 seconds of difference. And we reduce load time by 96%. And it's mind blow. It's only 100 of lines and it works 96% faster. I heard once that working with performance is an art of reduction, because we're always trying to reduce unnecessary things. We reduced today number of blocks, even listeners, change detection cycles, and again we reduced number of blocks. So I have one final advice for you if you work with performance. If you load less resourcing, it will load a lot faster. If you try to execute less code, execute will be shorter. If you try to render less elements, it will render faster. Less is the common word here. So basically, less is better. That's all for today. If you want my slides, my code, additional resources that I can recommend, you will find it in repository. Thank you again. Meet me after the presentation.